This is the solution for Unit 4 review, problem number 8. All right, so it says let f be a function that is even and continuous on the closed interval -3 to 3. The function f and its derivatives have the properties indicated in the table below. All right, so first thing we want to make sure we realize function is even, right? So what does that mean? That means f of negative x is equal to f of x, right? Or it's symmetric about the y-axis, right? So that means, an example of an even function would be like a parabola, right? With its vertex on the y-axis or something like this, right? Symmetric. All right. So it's important to understand that what we're only given here is we're only given information from 0 to 3, but this graph goes from -3 to 3, right? So we'll have to take whatever we get from 0 to 3 and reflect it over the y-axis. All right. Now, it says find the x coordinate of each point at which f attains an absolute maximum value or absolute minimum value. Find the x coordinate you give. State whether f attains the absolute maximum or an absolute minimum. All right. Then B, find the x coordinate of each point of inflection. Right. And then C, sketch the graph. I actually prefer to start with C, sketching the graph. All right. So I am going to draw some axes here. All right. And remember, we are going from -3 to +3, but we're going to initially start at 0 and do just this side because we're given from 0 to 3. All right, so first of all, it says f uh, of 0 is 1, right? So f of 0 is 1, so I'm going to put a point at 0, 1. All right, then it says from 0 to 1, f of x is positive, right? Meaning it's above the x-axis. But then f prime is negative and f double prime is positive, right? So negative f, let's change this, negative f prime and positive f double prime. So what does that mean? Decreasing and concave up, right? So I'm going from 0, 1 to 1, 0, right? Okay, so at 1, 0, right? And I have to connect these two with a decreasing concave up curve, right? So we're going to have this curve connecting those two. All right, next, all right, the first derivative is 0, right? And the second derivative is 0. All right. But then from 1 to 2, f is negative, meaning it's below the x-axis, right? And then f prime is negative and f double prime is negative. So what does that mean? Negative and negative means decrease and concave down, right? And then we're going to a point at 2 comma -1. All right. So there's a point at 2, -1 right there. All right. And then I have to connect those 2 points with a decreasing concave down curve. So something like, I guess I wish I would have, right? Something like that. All right. Meeting at that point. Let's try one more time. All right. Decreasing concave down. All right. Then from 2 to 3, all right, you are told that f is negative, so it's still below the x-axis, right? And then f prime is positive, right? So that means the function is increasing, all right? And f double prime is negative, which means it's still concave down. So positive, so increasing and concave down, all right? And so then we're going up. Now, we're not told the value of the function at 3, right? So let's just increase concave down, and let's say that it does meet at that point 3 comma 0, right? We don't know its value, but we know that there is an end point there because it's continuous on that closed interval. All right, so that is the graph from 0 to 3. So now what we need to do is we just need to draw this reflected over the y-axis, right? And so that means on this left side here, we have a concave up curve here, right? But it's increasing, right? Because remember, we're going left to right. Then we have this curve that is increasing and concave down. And then we have this curve here that is decreasing and concave down, right? So this is our graph. All right, so now it's going to make it a little easier to find out where the absolute maximum is. Look at this picture. Where's the absolute max? Well, the absolute max is very clearly at x equals 0, right? And what is the absolute maximum value, right? Well, the absolute maximum value is 1, right? But remember, it says find the x coordinate, okay? And then it says absolute minimum. Well, absolute minimum there and there. So at -2 and +2. So absolute minimum at x equals 2 and positive 2, right? They're at both of those because they both achieve that minimum value of -1. All right, then it says for each x coordinate, state whether it attains an absolute maximum or minimum, right? Okay, so we're done there. All right, next, B, find the x coordinate of each point of inflection. So remember, a point of inflection is when the concavity changes or when the second derivative changes signs. So second derivative, right, is undefined at 0, right? Then it's positive, then 0, then negative. So it changes signs at x equals 1, right? Then it's negative, undefined, and negative. So it does not change signs at x equals 2. So it changes at x equals 1, but then that means it also changes at x equals -1, right? Because it's concave down, then concave up. So points of inflection, sometimes I just write POI at x equals -1 and +1. All right, and so